Today, everybody want to talk about 6.4, which is exponential growth and decay. So, excuse me, we've been talking a lot about the exponent properties and what does it mean for something to have a negative exponent and all of these different types of things with exponents and rational exponents for that matter as well. So, it's been kind of hard to see. I know some kids and some people are asking, I know you ask this a lot, why? What does this have to do with anything ever? Well, a big part of this is getting to us to get to a point where we can understand exponential growth and decay and what that means. Okay, so exponential growth and decay sound really fancy. Maybe that they'd be difficult, but really it's a pretty simple idea. Okay, so there's going to be some equations or some formulas that I'm going to give you today and show you. Those do not need to be memorized. So whenever we have a quiz or a test on this stuff, you will be given those formulas to use. You just have to know when to use them. Okay, so what do growth and decay mean? And there's two little definitions right here, and you can probably figure out without me telling you. But growth is this one: is when a quantity increases by the same factor. So that would mean an example of it increases by times 2, times 3, times 4, whatever. So that is what we talked about. If you remember back, I believe it was in 6.1 with the tables. Okay, to show how do we know a table is exponential? Well, the pattern is we're multiplying by 2 every time, or we're multiplying by 3 every time. Or the same thing is a pattern can be exponential if it decreases, gets smaller by the same factor. So instead of thinking of dividing by 2, dividing by 3, so on and so forth, we need to think of that as multiplying by a half, multiplying by a third, multiplying by a fourth. So that would be what decay is something is decreasing by that same factor, and we are multiplying to get from one number to the next. Okay, so here is the growth function. Okay, here's the growth function. So it's y equals a times the quantity, or in parentheses, 1 plus r to the t. So obviously you have some different variables there. And again, this equation, whenever we do anything, will be given to you. You do not have to memorize it. Okay, here's what everything stands for. The a value is the initial value. It's the initial value. What are you starting with in the problem, with whatever it happens to be? Okay, R, you can probably figure this out on your own, but R stands for rate. And rate is a percentage, but it's the percent as a decimal. Okay, so when you have that rate, that percentage in there in that problem, you always got to change it to a decimal before you put it in to this equation, otherwise it's not going to work. And then finally, T, you can probably guess as well, that stands for time. All right, so how many years? Okay, so all we got to do then is to, when we look at a problem, is to identify the values and what goes into it. So here, this is a good example of an exponential growth problem, is a town has a population of 17,000 people in 2015 and is growing at a rate of 9% per year. What is the population in 2025? So this would be a good example of a problem that is a real life problem. Honestly, it's probably a problem that, or something that the people that are in charge of Liberty Public Schools looked at a lot when they decided to build all the new elementary schools that they have over the last 10 or 15 years. And how did they decide to build another high school and that kind of stuff? They probably used some sort of model like this in deciding that that would be a good idea of looking at how is the population growing, so what is it going to look like 10 years down the road if this continues to happen. Okay, so all we're going to do now is use that equation, the growth function, and I know it's a growth function because it says that it's growing at a rate. So when I told you at the beginning, all you have to do is be able to know or look at the problem and read which one am I going to have to use. It's usually pretty obvious in the problem. It's growing at a rate of 9% per year. So here's the equation. Here's what it's going to look like. So y equals, and again here the a value is going to be the initial or that starting value, which in this case would be 17,000. And then 1 plus r, the rate is 9%. So to change 9% as a decimal, and remember, you got to be careful with this. You always move it 2 spots. That would be 0.09. Okay, now here for the time, what would that be? So it says the population was that in 2015. We're trying to figure out what the population is in 2025. 2015 to 2025 is a difference of 10 years, so the time is 10. Okay, so they might not come out and just tell you right away what the t value is. You might have to figure it out, but again, it's just where am I starting, where am I ending? Okay, and now with my calculators that I have, you could enter this problem in exactly like it sits, just like this, and get the answer. Okay, really, the only other thing that we could do to make this simpler, that would be very simple to do, would be to combine this part right here. Okay, 1 plus 0.09 is 1.09, which you probably won't need a calculator for anyway. Okay, so now this part we can enter in the calculator to get our final answer. And again, when you do these on big ideas, make sure you pay attention to what it says. What place value are you supposed to round off to, that kind of thing. So since this says population, I'm just going to round it off to the nearest whole number. And when I do that, and again, this anytime would be a good time like this stuff to pause it, like pause the video, put it into your calculator, see if you get it right. Okay, instead of just listening to me get the right answer. So I got 40,245 people. Okay, if this kept growing at 9% per year. Excuse me. And another thing to know is there's a few problems that you'll see that I won't necessarily show you an exact example of it on here, but there will be examples on there or problems where they will give you an equation and they will ask you if that equation represents a growth or a decay. Okay, growth or decay. So let me show you the decay function real quick. It is exactly like the growth function, except it's minus instead of plus. Okay, so I'm actually going to come back to that question after we do our decay problem. Okay, so I'm not going to label A and R and T again. It's the same values or the same things as it was up above. We are just subtracting that rate from 1 instead of adding it. Okay, here's another, again, very good problem, very good real life type example. You bought a car for $19,500 in 2014. Its value decreases by 11% per year. What will its value be in 2021? So again, very good real life problem. A very, very large percentage of the population has a car or has bought a car at some point in their life. And this is something that's good to see. When I'm buying a car, what is its resale value typically going to be and that kind of thing. Okay, so we're going to do the exact same thing we did on the problem up above with the population. Starting value is 19,500. Okay, I'm going to go 1 minus this time because it's decaying. It's decreasing. Again, it's usually very obvious in the problem if it's growth or decay. And 11% would be 0.11. And then what do we need? Time yet. So the time, what will its value be in 2021? So from 2014 to 2021, that would be a difference of 7 years. So T will be 7. Okay, so you can see obviously very similar to one up above. Again, I'm going to simplify this part before I decide to plug it into my calculator, just because that will make it a little bit easier to work with. So 1 minus 0.11, 0.11 would be 0.89 to the 7th power. And remember, exponents have to be done first, this one and the one up above. Okay, so if, and this is where some of us get in trouble sometimes on our calculator. If you do 19,500 times 0.89 and then take that and then hit enter and then take that to the 7th power, that will be wrong. You've got to do the exponent first. So again, the best thing to do would be to enter this entire thing in at once, so you don't even have to worry about that part of it. Okay, but when you do that, and we're talking about what? We're talking about money this time. So this time I'm going to go to the nearest cent. So I got $8,625.11. Okay, so after 7 years, this car will go way down in value overall. Okay, that's less than half of what it was originally purchased for. Okay, and obviously this isn't always the case. Of course, it can depend on what kind of car you buy and those kinds of things and mileage and what it looks like, but this is just in general a good idea to look at when you're buying a car. Okay, so another thing I wanted to show you that I said I'm not going to show you an exact example of, but you're going to see in the assignment is they will give you an equation that looks like, and I'm going to highlight these things, that could look like this one up here or this one down here. Okay, so if you can imagine for a second that we took away the problem, we took away the word problems for these, and that gave you just the equation, y equals 17,000 times 1.09 to the 10th, or y equals 19,500 times 0.89 to the 7th. Just by looking at those equations, how can I tell if that's a growth equation or a decay equation? Okay, well the key is looking at this number right here, 1.09 or 0.89. Okay, if that number in there is more than 1, then I know it's a growth problem because it was 1 plus the rate. If that number is less than 1, then I know that must have been a decay problem because I subtracted my rate from 1. So again, more than 1, it's got to be a growth problem. Less than 1, it has to be a decay problem. Doesn't matter what the A value is. Doesn't matter what the time is. What matters is what's that number inside there. Is it more than 1 or is it less than 1? More than 1 growth, less than 1, we know it's a decay. Okay, so let's move on. Kind of the next thing is compound interest. And this, again, good real life example. It's interest earned on money and previously earned interest. It's used for borrowing for a loan or investing, or even if any of you have a savings account. This could be something like that. All savings accounts get a very, very small interest rate added onto them every so often. Excuse me, or again, I could use a loan. Again, I could use a good car example, would be another good one there. If I go buy a car, okay, a lot of times when people buy a car, they have to take out a loan. When they buy a house, they have to take out a loan. So you hear those things on TV a lot, or if you don't, if you pay attention to a few commercials here and there, you're going to hear that stuff. Car commercials, they talk about that all the time, is they'll advertise that they have 0% interest for their financing, which means the amount of money that you borrow is the exact amount of money that you pay back. So obviously that's a pretty big deal to people. But anything else, like for a house loan or anything like that, you're going to get charged an interest rate, okay, and that's going to get compounded every so often, and that's what we're going to look at. And so the amount of money you borrow, so if you buy a house that's $200,000, you are going to pay back way more than $200,000. That's how those people make their money, is by using those interest rates. And that's why where credit cards you have to be incredibly careful with, because they have a very high interest rate. So let's look at what this means instead of me just talking forever. Okay. This equation, again, you will get it. You won't have to memorize it. I know when you first look at that, it looks kind of intimidating. But again, you don't have to memorize it. All you got to do is be able to use it, okay? And obviously know what these things stand for. So capital P right here, that stands for principal. Okay, that is the amount of money you're starting with. Okay, interest, this is a money thing. Okay, so that is always, what is the amount of money that I'm starting with? How much am I borrowing? How much do I have? How much am I investing? Okay, that kind of thing. Okay, R still stands for rate. T still stands for time. Okay, now the N. N here and N here, obviously those are the same thing. Those stand for the number of times interest is compounded per year. Number of times the interest is compounded per year. Okay, so you can see that down there. There's different values that we could get for N. Okay, it's not just going to be the same thing. And here's what this means, and I have kind of a list here of things that you might see in these problems. Okay, so it's how many times it's compounded per year. So if it says it's compounded yearly, then N would equal 1. Semi-annually means twice. N would be 2. Quarterly would be 4 quarters. Okay, quarterly would be 4 times a year. Monthly would be 12 because there's 12 months in a year. And daily would be 365 because there's 365 days in a year, most of the time. Okay, so those would be the different possibilities of how interest is compounded. Okay, monthly and daily aren't very common. Yearly, semi-annual, quarterly, those are the more commonly used types of ones. But any one of those could be a possibility. So let's look at a problem. Okay, and again, it's got to be a word problem here. So you invest $10,000 at 5.2% interest compounded quarterly. How much is this worth in 5 years? Okay, so what does this mean? So people that they have money, if they have money, they can invest it. Stock market, other types of things. And when they do that, they will put it into, and a lot of times these people, that's their job, is they invest people's money, and they will give you statistics or things that if you invest your money in this type of thing, we can promise you, or over the time, we can promise 5% interest, 7% interest, whatever, something like that. Okay, so if this is what we would expect or what we're hoping to get, how much would this be worth in 5 years? So now again, all we got to do is just like with growth and decay, we have to plug the numbers into the equation and then just work it out on our calculator. So y equals, let me scoot up here to this. I can't get that high without covering everything up. So it's P, which is principal, so that's the amount of money I'm starting with, which is $10,000. P times 1 plus, okay, now this we have to do the rate over N. So the rate is 5.2%. As a decimal, that would be 0.052 over, and then the N is how many times is it compounded per year. Quarterly, like we showed up above, quarterly would mean 4. So that's going to be a 4 right there. And then on the outside, or for the exponent, it's going to be N times T. So N was 4 because we're compounding this quarterly. Time is 5, so that will be a 5. Okay, now, when I put this in my calculator, I'm not going to make this 4 times 5. I'm going to make this 20. Make that a lot easier on myself. Okay, and again, you can type this exact thing into your calculator with the parentheses, with all that kind of stuff, and you should work it out. Now, one thing, when you put in your .052 over 4, don't use the fraction button. Okay, the calculator for some reason doesn't like it when you do that. So you can put your 10,000 in, you can put in a parenthesis, you can put 1 plus, and then when you do 1 plus, do .052 divided by 4, close the parentheses, and then use your little arrow button, your little half arrow button for your exponent of 20. Okay, so I'm going to write the answer down here in just a second. So if you want to pause it and work it out on your calculator yourself and see if you can get it, now would be a good time to do that. Okay, so if you type all that in, enter it into your calculator, you should get around, and again, money, I'm going to round this to the nearest cent, $12,947.59. Okay, so if you invest $10,000 into whatever this is, and they're saying that you're going to get about 5.2% interest back, then that means over time, over 5 years, you would gain almost $3,000. You started at $10,000, now you're almost at $13,000. So in those 5 years, you'd gain $3,000. Okay, which over 5 years, $3,000, that's not very much, but obviously that's better than nothing if all you have to do is let it sit there and work on that on its own. Okay, so that's a good thing. That's a nice one where I'm investing money and I'm gaining money back just by letting it sit in there. And the same thing happens for your bank account, for your savings account. Okay, the interest rate is very, very, very small that the bank lets you have, but it's something. So obviously the more you invest with those interest rates, the more money you're going to get back. Okay, last problem that I have on here is the same type of problem, compounding interest, but this is the time you borrow. Okay, so you borrow $12,200. So let's say this is a car loan problem. This is a pretty good one. You borrow $12,200 at 4.5% interest, compounded semi-annually. What is the total amount of loan if it is for T years? Now, you see I put T in red. Okay, so for some reason on Big Ideas, instead of saying how many years it is, like this one said 5 and figuring it out, they always put a T in there instead. Okay, so instead of actually working this all the way out, all we're going to do is write the equation and then simplify it a little bit before we put in our answer, and then our answer is going to be the equation. We're not actually going to find the exact number answer. Okay, so again, using the equation, y equals, the principal is $12,200 times 1 plus the rate is 4.5%. That would be 0.045 as the decimal. Compounded, where is that? Semi-annually. That means twice a year, so n is 2. So it'll be over 2 right there. And then it'll be 2. Now, instead of times t, how many years am I have? I don't know how many years I'm going to have, so I'm just going to put a t there. Okay, now since we don't know what t is, we're not told what it is, the only thing that we can do with this problem, to simplify it at all, is we can figure out what this value is. Okay, I can go to my calculator and do what's 1 plus 0.045 divided by 2. Okay, remember, don't use the fraction button, use the division button for that. Okay, so again, if you want to pause that and try it, because I'm going to tell you the answer right now. So that'll give me 12,200 times, and if I take 1 plus 0.045 divided by 2, that'll give me 1.0225, and again to the 2t. This would be my final equation. I cannot simplify this any further. You cannot take 12,200 times 1.0225, okay, because with what we have set up, we would have to do the exponent first for order of operations. Okay, so on Big Ideas, it's going to be more like this type of problem instead of actually figuring out what it would be. Okay, all right, but again, too, I could easily change this problem just to kind of give you an idea of how loans work and what that means. Instead of saying that you invest $10,000 at 5.2% interest, what if this was you were borrowing $10,000? Again, good car problem. The car costs, you're buying a used car, it's $10,000. Your interest rate is 5.2%, which isn't that great, but whatever. And you're going to take 5 years to pay it back. That would mean if you have a $10,000 loan, you would actually end up paying $12,947.59 back in total. So that's why you hear that about why interest rates are so popular for people to talk about on commercials. Okay, because obviously the lower the interest rate, the better it is for you, because that means you'll have to pay less money, whether it's for a car, for a house. And if you think about for a house, houses are really expensive, hundreds of thousands of dollars, even for a small house, hundreds of thousands of dollars. If you have even a small interest rate, a lot of times home loans are either for 15 years or 30 years. Okay, so if you calculate that out, and a lot of people don't do it, they just say, oh, this is how much the house costs, this is my interest rate, great, I think I can afford it, and I'll sign the papers. And so this is a good idea for you to know, not only now, but as an adult, to figure out exactly what you're paying for different types of loans. Okay, so that should be it for this. Any questions on the assignment? Let me know, otherwise good luck.